This is Chapter 2.4, Classifying Figures on a Coordinate Grid, page 102, and we're doing question 4a. So the question says, triangle DEF has vertices at D, which is -3 and -4, E, which is -2 and 4, and F, which is 5 and -5. So the question asks, show that triangle DEF is an isosceles. We can do it using equations. So what we need to do is, actually first we'll draw out our triangle. So we know an isosceles triangle has two sides that are the same and two angles that are the same. So that's what we're looking for when we find our answer. So if this is our triangle and we have vertice D, vertice E, and vertice F. So we need to find the distance between D and E, D and F and E. And once we find the distance, and we find that two of the distances are the same, and one of them is different, then we'll know that triangle DEF is an isosceles. So let's start doing some of these equations. So first, let's find the distance between D and E. So D and E. So we know that the distance equation is D and then to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now we have to plug in our numbers. So we know that x2 is -2. These are our coordinates. So this is x, this is y, this is x, and this is y. So d to the square root, d equals x2, which is -2, minus x1, which is -3, to the power of 2, plus y2, which is 4, minus -4, which is y2 over there. I mean y1, to the power of 2. Okay, so now let's solve. So first we have to do what's inside of the brackets. So -2 minus -3 is 1 to the power of 2, plus -4 minus 4 is 8 to the power of 2. 1 to the power of 2 is still 1. One plus 8 to the power of 2 is 64. And then that equals 65. And now we have to just find the square root. So the square root of 65 is around 8.1 if we round up. Okay, so now we know that from D to E, so one of our sides on the triangle is 8.1 units. Okay, now let's find out side DF. So now we're finding this side. So DF. Let's write out our equation again. So x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay. So now that we have our equation right now, we'll just have to plug in our numbers again. So we're doing D and F. So this is our x value, this is our y value. So we need to plug in our equations now. So x2 minus x1, so 5 minus -3, 5 to the power of 2, plus y2 minus y1, so -5 minus -4 to the power of 2. Okay, so now let's subtract in the brackets. So that is negative, that's 8 to the power of 2 plus negative 1 to the power of 2. Okay, and that ends up being 64 plus 1, which ends up giving us 65. And these are familiar, so we know that side DF is equal to 8.1 units. So now we know that these two sides are the same. So DF and DE are the same. So now we need to find out, just to be sure, side FE, and that side should be different than these two if it's an isosceles triangle. So let's just do that last equation. So now we're finding out EF, side EF. So that's this one right here. So let's write out our equation. Distance equals x2 minus x1 to the power of 2, and y plus y2 minus y1 to the power of 2. Okay, so now let's plug in our numbers. So distance equals, we're doing negative, so x2 minus x1, 5 minus negative 2, 5 minus negative 2 to the power of 2, plus negative 5 minus 4 to the power of 2. Okay, so now distance equals 5 minus negative 2, which equals 7 to the power of 2, plus negative 5 minus 4 equals negative 9 to the power of 2. And then we have to, and then 7 to the power of 2 is 49. And then negative 9 to the power of 2 is 81. And that ends up being, when we add them together, 130. And we can already tell that this is different than side DE and DF, so it's looking like this is an isosceles triangle. So this ends up being 11.4 units. Okay, so now we have all of our sides. We have sides DE, which is 8.1 units, sides DF, which is also 8.1 units, and side EF, which is 11.4 units. So since there are two sides that are the same and one side that is different, triangle DEF is an isosceles triangle, and we've proved that by finding the distance of each side and understanding that two of them are the same and one of them is different, which is the requirements for an isosceles triangle.